All right, factorial, remember, means that you're going to multiply the number times every number less than it. So you can just calculate 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and it will work if you forget how to find your factorial button. However, there is a factorial button. If you press the 8 and then you press math, you can go over to probability, and it's choice 4. All right, and that's going to give you the answer for 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's 40,320. Okay, the next one, most of you entered that in your calculator. You entered 6 factorial, you did 4 factorial, and you divided them, and you got how much?
30.
Anybody else get 30? Okay. Yeah, you do get 30. That's good. If you think about it, it's actually a problem you can do in your head. Let me show you how. 6 times 5 times 4 times 3 times 2 times 1 divided by 4 times 3 times 2 times 1. What happens with our numerator and denominator?
Cancel.
Yes. So if we cancel out the 4, 3, 2, 1, we're just left with 6 times what?
5.
Yeah. So it's fine to use the calculator, but it's interesting to notice that you could just do that problem in your head. It would just be 6 times 5, which is still 30. Any questions on that? All right. If you do this in your calculator, you might want to calculate the top separate from the bottom just to make sure you don't make a mistake. Again, this is one that you could simplify and do in your head, but you don't have to. I'm going to do this on the calculator. So I'm going to do 9 factorial, 9 math, go over to probability and choose 4. And then I'm going to do 7 factorial, 3 factorial. All right, and so then I want to do 362,000. 362,880. Oops. 880. And then divided by 30,240. So I got 12. Anybody else get 12? No? So it might be because you tried to do it all at once, because if you put it all in once, the order of operations would not help you out there.
Wait, how?
What you could do is put parentheses around your denominator, and that would work.
Oh, non-numerator?
You can also do the numerator.
I did do parentheses on my denominator.
Did you put 1 in front of the 7 and 1 after this?
Yeah.
Okay, I'll look at your screen, but it should have worked.
Like separately?
Mm-hmm.
Like
Yes, separately. They're together, like the whole thing, around the whole thing. Yeah. So what you want to do in your calculator is put a set of parentheses around your whole denominator, because there's more than one thing there. You could also put it on your numerator, it wouldn't hurt, but definitely on your denominator. This should give you 12. Or you could just do it separately like I did, and then divide the numerator by the denominator. All right, so this one, you can enter it like this if you want, but 6 minus 2 is not hard, right? What is it? 4. So you can save yourself some typing if you just do 7 factorial over 4 factorial. Okay? Remember that the 4, 3, 2, 1 is going to cancel, so if you want to do that in your head, you can do 7 times 6 times 5. But you can also just do it the way it's written. Okay? All right, actually, I'm going to go back and just edit this one. So I'm going to do second, enter. Oh, second, enter. And I'm going to go back and edit this. I can insert with second insert, a division, and a parentheses. And then I'm going to make this a 4. Delete that. And then close these parentheses. So I got 210. Anybody else get 210? Nice work. Okay. All right, who's having trouble making this work on your calculator? Okay. All right. So The reason we're introducing these these factorials is because they're used in the formulas for permutations and combinations. So the number of permutations of R objects taken from a group of n distinct objects is denoted by n PR, and it's given by a formula, which I don't have in front. Hold on one second. Give me 1 second. I'm going to pull up this formula for you. Where's algebra? All right, here's your formula. N factorial over n minus r factorial. So remember that you have n things. N is the total you have. And then r is how many you're taking. How many you're selecting.
Would it change the answer if you put the factorial like in the parentheses?
Yes, yeah, it would. So you're gonna do it this way, okay? It says in a certain order. So sometimes the order doesn't matter. Remember, like when we did our warm-up, sometimes the order doesn't matter. But in the permutation, the order does matter. I'm going to suggest that you just do the numerator and denominator separately and then divide just to make sure you don't make a mistake. So I need everybody's attention so we can do. In problem 5, we are selecting 2 out of 25. So the total you have is your n. And then how many you're selecting is r. The reason why the order is important here is because we're selecting them for different jobs. So the first one will be selected as president and the second one as vice president. I'm using this formula. So it's going to be 25 factorial divided by 25 minus 2 factorial. Just like with that previous problem, you can type 25 minus 2 factorial, but it saves you some typing if you just think, oh, that's 23 factorial. It's going to save you a little bit of typing. All right, remember, if you didn't have a calculator and you were stuck doing this problem, I would probably take that shortcut of crossing out the 23 times 22 times 21, all of those. You would just be left with 25 times 24, which is a much easier problem. I'm going to enter it exactly how I see it. Well, actually, I'm going to enter the numerator separate from the denominator. So 25 factorial. Math. Whoa, I don't want to deal with that number. All right, I'm just going to put extra set of parentheses on each of these. So 25 factorial. Because it's not going to end up being so huge. So I'm putting parentheses around my numerator.
Wait, doesn't it go at what?
25 factorial was so big I didn't want to deal with it. So I'm going to put parentheses on my numerator and denominator. And then I'm going to put in 23 factorial down here. Like that, okay? So I did 25 factorial in parentheses, then divided by, and then 23 factorial in parentheses. And I'm going to get a big number, but it's not crazy big like that last one, 600.
Oh. I did the factorial outside of parentheses and this one was 16.
Okay.
Does that just make a coincidence?
I would say sometimes that might work and sometimes it might not. Okay. There are 8 finalists in the 100-meter dash. So 8, is that going to be the N or the R? N, right. How many ways can they finish first, second, and third? So what is R going to be? How many are we picking?
3.
3. So R is going to be 3. Okay, so I want you to go ahead and use your formula now to find how many ways you could choose the 3 winners. All right, so we had 8 factorial over 8 minus 3 factorial. 8 factorial over 5 factorial. What did we get? 336, yeah. So if you didn't get 336, it's possible that you forgot some parentheses. That might have been it. I'm not sure. Okay. So in 7, there's 2 parts. First is how many ways could you choose the batting order for all 9 players? So what would N be in this case? The 9 players, right? And how many are we picking? Also 9. So your N is 9 and your R is 9. And then in B, it's going to switch it up a little bit. Okay? So I want you guys to work on 7A and B. All right, guys. So in number 7, there are 9 players, and we're putting all 9 of them in order. So it's 9 factorial over 9 minus 9 factorial, which gives us 0 factorial, and we know we can't divide by 0. But 0 factorial doesn't equal 0. It tells you up top that 0 factorial equals 1, right? So this is going to be 9 factorial divided by 1, which is just 9 factorial. Can you guys give me a sec? I want to explain another reason why our answer is 9 factorial here, which is that there are 9 players, okay? You have 9 choices for the first batter. Then you take away 1. You have 8 choices for the next batter. Then you have 7 choices, and then you have 6. And as you keep placing somebody, you have fewer choices for the next batter. So that's why 9 factorial, remember, is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's why. Because 9 choices for the first, 8 choices for the second, etc. So all of these permutation problems could be done with that fundamental counting principle, where you just multiply the number of choices for the first times the second times the third. On the back, it's a little bit more complicated because when the order doesn't matter, it actually complicates the problem a little bit. But this is 9 factorial over 0 factorial, which is 9 factorial, which should give you 362,880, right? Did you guys get that? All right, your calculator, though, doesn't even need you to work that hard. On your calculator, if you go to math and you go over to probability and you choose NPR, choice 2, then we can put in that there are 9 players and we're choosing 9 of them, and it will also give you the same answer. Do you guys want to try that for B? So in B, there are still 9 players, right? So N equals 9. And we're choosing 4 of them, first, second, third, and catcher. So R equals 4. So on your calculator, you can do 9P4. Let's practice that because it saves you a little bit of time. Go to your calculator. Press math. Go over to probability and choose choice 2. And it's going to be 9. Choose 4. And we get 3,024. Is that what you got also when you did it by hand?
It's different on here.
Okay, let's look at yours. All right, so we're going to try it on here. So you're going to press math. Go over to probability. Choose 2. Why does it say answer though? Why does it keep saying
Yeah.
answer? Oh, I know why. Because it wants you to put a number in first. So we're gonna put in 9. So press 9, and then press math, and then choose NPR, and then put in 4. And that's gonna work. Got it?
May I go to the bathroom?
Did you do 10 to the exponent equals whatever that expression was, 2x? Are you on that problem still?
Yeah, I don't know how to put like the
What does the problem say? Log what?
log 2x plus 8
Equals 2? All right, so the base of the log when it doesn't say is 10.
Yeah.
So you write 10 to the 2. And that's going to equal,
like to the power.
yeah.
Oh,
And then it's going to equal 2x plus, what is it?
I thought you had to put it to, like where it was like on the bottom. Like,
No.
okay, I was trying to figure it
Yeah, and so then that's what you're solving. Okay. All right, so this one gave us, oh, I already forgot. 3,024. Okay. Next year you are taking math, English, history, physics, art, Spanish, and psychology. So 1, 2, 3, 4, 5, 6, 7 classes. How many different orders? So you have 7 classes, and you're putting how many of them in order? Nate, 7 classes. How many are you putting in order?
7.
Yep. So n equals 7, r equals 7. You can do 7 factorial over 7 minus 7 factorial, or you can do 7 NPR 7 on your calculator. And either way, you're going to get 5,040 different schedules. So that's kind of crazy to think about. Taking the 7 classes you're taking this year, there are actually 5,040 different ways that your schedule could have been arranged. It's a lot. All right. So when you choose things and the order is not important, if the order is not important, it's a combination. Okay? So it's a permutation when the order is important. Right here, we circled order. It's a permutation. And it's a combination when the order is not important. The formulas for finding the number of combinations is n factorial over r factorial times n minus r factorial. We are going to put an extra set of parentheses on that denominator so that if you put that in your calculator, it will all stay together. Okay? Who has a question on the formula? So a group of R students working on a project needs to choose 2 from their group to present the group's report to class. How many ways can they choose the 2? It doesn't matter who they pick first, okay? If they pick Addie and Yumna, it doesn't matter if they say Addie and Yumna or Yumna and Addie. Those are still the 2 people presenting the project, okay? So we're going to use this formula. So we're going to do on the top, and oh, how many are we choosing from? We're choosing from 5, and we're choosing how many? 2, so that's your R. Okay, so n is 5, r is 2, so we're going to do 5 factorial over, let's see, it says r2, 2 factorial times 5 minus 2 factorial. All right. You might want to simplify that to be 5 factorial over 2 factorial, 3 factorial. It's up to you. Put that in the calculator and let's find your answer. All right, so we said 5 factorial over, and then put parentheses around your denominator, 2 factorial 3 factorial. And I got 10. Anybody else get 10? Okay, good. Guys, you should all be practicing doing this on the calculator so you'll know how to do it. There are really two things that make this hard, because using a formula is not hard. The first thing that makes it hard is deciding if it's permutation or combination, so you need to know if the order matters. The second thing that makes it hard is knowing what number is n and what number is r. After that, you're good. All right, standard deck of playing cards contains 52 cards, 4 suits of 13 cards, 5 cards are drawn. How many different hands are possible? All right, so I feel like this here is extra information we don't need. So there are 52 cards, and we want to know how many different hands are possible. If 5 cards are drawn. So there are 52. This is my n. And then what's my r? R is 5. Okay, so go ahead and find your answer there. Okay, so this would be 52 factorial over 52 minus 5 factorial, which is 47 factorial. You should get 2,598,960. Any questions on that one? All right, and again, there's a shortcut formula on your calculator for combinations as well. It's the NCR formula. So on your calculator, let's see, if your N is 15, and your R is 4, then you're going to press 14, and then NCR, and then 4. And that should get you your answer as well. So of course you can use the formula, or you can use the calculator to figure this out. 14 NCR 4, 14, and then math, probability, NCR 4. And I get 1001. That's actually not what I'm supposed to get, is it? It's 15. Okay, so let's go back. Fix my paper first. It's like, why is that answer wrong? 15 here and here. Okay, second, enter. Let me go back and change it to 15. All right, is that better? 1,365? Okay. All right, guys, we have one more topic to go over. And so I need to know what questions you have first on combinations and permutations before we do this last topic. Okay. If you have more complicated situations, you might need to multiply or add combinations. If they both have to happen, you're going to multiply combinations. If you just want one or the other to happen, then you're going to add the combinations. So there are 10 juniors and 14 seniors in the leadership class. A committee of 2 juniors and 3 seniors is being created to organize the fundraising project. How many different committees can be formed? First question, is this permutations or combinations? Permutations if it matters what order I pick, and combinations if it doesn't. So when I'm picking 2 juniors out of 10, does it matter if I pick Addie and Yumna, or if I pick Yumna and Addie? Like, does it matter what order? No. So that would make it a what? Permutation. Oh wait, you're right, combination. Combination is when the order is not important. So this is combination. Okay, and for the juniors, there's 10 of them. And we're choosing 2. For the seniors, there are 14 of them. And we're choosing 3. And so the last thing we have to figure out is, are we multiplying or adding? And the word right here is going to help us, right? So the word is and, so that means we're doing what? When it says and, you multiply. So it's not that you want 2 juniors or you want 3 seniors. You want 2 juniors and 3 seniors, so you're going to multiply those. All right, so go ahead and find your answer for that one. It's a little bit of typing, but doing it's going to help you know what you're doing. All right, 16,380. Anybody get that?
I didn't get it.
16,380. All right, you are planning a trip to the beach. Your parents said you could invite 1 or 2 or 3 friends to go with you. If you're choosing from 6 friends, how many different groupings can be formed? All right, first of all, if you chose 3 friends, does it matter if you said Landon and PJ and Taylor, or if you said Taylor and PJ and Landon? Does it matter? No. So the order doesn't matter, which makes it combination. Still right. All right, and then we're choosing from 6. So we have 6 NCR, and you could choose 1, right? Or, so plus. You could choose 2.
Where we can't see it.
Or you could choose 3. Okay, so there are a certain number of ways to choose 1, plus the number of ways to choose 2, plus the number of ways to choose 3. Take a moment, get that answer, and then look at the last part about the frozen yogurt.
I don't know.
I thought you just said you knew the answer.
I don't know.
Permutation.
Who has an answer? Go ahead.
41.
Anybody else get 41? It's
Yeah.
right. All right. Frozen Yogurt Shop offers 12 toppings for your yogurt. How many different 3-topping yogurts can be made with the 12 topping, assuming no topping can be used twice? All right, so we have 12, and we're choosing 3. So it was just that simple, all right? 12, choose 3. You're going to get that answer. And then the last one, it says up to 3 toppings. So it could be 1 topping or 2 toppings or 3 toppings. Actually, it could also be 0 toppings. We should put that in there. It says up to 3. So it could be 0 or 1 or 2 or 3. Actually, this is not how you guys write it. Sorry. You guys write 3 NCR 12. Oh, guys, you need to stop me when I say the wrong thing. 12 NCR 3 plus 12 NCR 2 plus 12 NCR 1 plus 12 NCR 0. For this one, you should have gotten 220, and now you're going to find this one. All right, guys, you should have got the same answer as Jennifer, 298. Any questions?
I got 99.
Oh, wait, 290 what? 99. Yes, you're right. You got 299. And that's because before I forgot to add in this one, which is 1. So it's actually 299. You guys are absolutely right.